Hi, Amy. How are you?
Hi, sir. Yes, I'm doing well, thank you. How are you?
Good, good. So, how is winter going on?
So it's not as bad as when I last told you. It's actually getting a little bit warmer, but
Mhm.
windier as well. But
Okay,
the ice and everything has calmed down. It's not like bone chilling or anything. Yeah, so
right.
it's okay. Just windy. Yeah.
Even then, take care. So,
Yes.
today, what do we begin with?
So is it all right if we could continue with our probability kind of chapter where we're just I think the last thing we covered was conditional probability.
Right.
We touched upon it, but not fully. So
We
yeah,
can continue. We can continue. Yeah. You can share whatever you have, and then from there we'll begin.
yeah. So the probability of an event can change depending on the outcome of a previous event. For
Mhm.
example, the probability of you being late to work may change depending on whether you oversleep or not.
Correct.
So situations like this can be modeled using conditional probability. Use you use a vertical line to indicate conditional probabilities.
Okay.
So like the tree diagram stuff.
Right. Okay. Read.
The probability that B occurs, given that C has already occurred,
A
is
has
written
already
as
occurred is given by this, right? So, when you
yeah.
write P probability of B when A has already occurred. So this event A has occurred. We need to find now what is the probability of B, correct? That is what it is, correct?
Oh, okay. So the one that comes after the line is the one that's occurred.
Happened. So now basically if you look at it, so well, how I deal with it is if something has occurred, then our domain has changed. We're looking into only the domain of what has occurred, correct?
Yeah, yeah.
So, for example, I'm throwing two dice, correct? Then let's say one die after the other. You can get six numbers. But now I'm saying, what is the probability of getting a number which is more than three if in the first row I have got a six? You get the idea.
Oh, okay.
That
Yeah.
really means that I have to only look into the cases where the first row was six and three or more will means that their sum should have been 9, 10,
Uh,
11, or 12. You get the idea.
yeah, yeah.
So I'm
That
only
makes
looking
sense.
into the two columns, one column with six, the other row with six. And within these rows and columns, I'm only checking the numbers, which are nine or more. So I know that
Right.
we got 6 and 5, 11 numbers in all. And out of these 11, how many do give me a sum which is 9 or more? So that number over 11 becomes my answer. You get the idea.
Yeah, yeah.
The main
So
is
you're saying
restricted.
because of the first condition, it restricts what your second one can be.
Yes. And so that becomes my
Oh,
total number of options. And out of those options, we are looking for favorable options now. You get the idea.
right. Yeah, yeah.
So if you apply this concept, then you can do many questions without applying any formula, right? That's the
Oh,
that's
okay.
the beauty of it, right? So continue reading. Let's see what is this. Similarly,
So similarly, probability
B
of
occurring.
B, given that A has not occurred,
Yes.
describes the probability of B occurring given that. Oh, it just
Yes. No,
it says
correct.
it there.
You
Okay.
have understood. Yes. Yes.
Yeah, I've understood. Okay, so for independent events, probability of A given B equals the probability of A not given
Not B.
B
Yeah. It is
and
independent of
equals
whether B happened, occurred, or did not occur. Do you see that? Probability of A
uh,
is independent of whether the event B occurred or not occurred. So that means
oh yeah,
probability
yeah.
of A if B occurred or probability of A if B did not occur remains same. So it is not affected. Correct?
Right.
That is called an independent event. When we talk about conditional probability, is that clear to you?
Yeah, yeah.
Correct. Yes.
So you can use this condition to determine independence. You
Yes.
can solve some problems involving conditional probability by considering a restricted sample space of the outcomes when one event has already occurred.
Yeah, this is what I was talking about. Restricted sample space. So we have restricted our domain. That's what I meant, right? Okay, so let's take an example. Example 3 here is a school has 75 students in year 12. Of these students, 25 students study only humanities subject H and 37 study only science subject S. 11 students study both science and humanities subjects. Draw a two-way table to show this information and then find the other probabilities. Now, what is a two-way table? Tell me, how will you draw this? Draw a two-way table to show this information. So that basically means that either a student will take humanities or will not take humanities, right?
Yeah.
Similarly, a student may take science, may not take science. So that is what it is, right?
Yeah.
So let's say humanities, not humanities, science, not science. Now we need to fill this out. So there are total 75 students. Of these, 25 study only humanities.
So that would be in the H. So S dash and then H column.
Correct.
Box.
So 25 in this particular box.
Yeah.
And 37 study only science. 11 study both science and humanities.
Oh, so then you add them up.
Okay, and total is 75.
73. So that means 2 in the none.
Yeah, so 75 take away that.
So 2.
So you got that, right? 11 plus 7 plus 25. So you say it is 2, right?
Yeah.
So we got this. So once you have a table, you have all the information. Now, find probability of not science intersection not. Okay.
So probability of S given H. So given
so
H.
Emmy, first
is
thing
this
first,
one.
is this clear to you? 2 over 75.
Yeah, very clear.
So can you
Wait, so
shade
would my method work? So if it says
So in your method,
probability
just
of
shade
S.
from S, not S, and not H. What do you get? I like your shading. Right? That is what is common. So it is not S and not H, and that is 2, and that is how you get this value. Is that clear to you?
Very clear.
Perfect. So you can erase your shading on this. That's good. And now tell me the answer for probability of science when it is given that a person has taken humanities, right?
Yeah.
So this
given humanities
shade
should
this,
be.
yeah.
So
Shade
given
this.
humanities should be this column.
Correct.
But we're saying given
S.
we just want to find the probability of S. So it should be
11 over what is this total? At this,
25 plus 11.
yeah. So it is
36.
6 and 6. So it is 11 over 36. Is that clear to you?
Oh, yeah.
Correct? So you can now erase. I like this idea. Erase this and not shade, because if I shade and erase, I have to go 2 times undo. This is very.
Oh, yeah. No worries.
Okay.
I like doing it.
So do the next one. Probability of humanities when the student is not taking science.
So not taking S, you would color
Yeah.
whole thing.
Correct.
And you want to find H. So it would be
Yeah. This thing.
But they overlap here.
25.
Out of 27.
Out of 27. That is very important. You have to see that the domain is what has occurred. What has occurred. And therefore, this time we are dividing by 27, not by 36. Is that
right?
Clear? Do you
very
understand?
clear. So restricted domain is very important when it comes to conditional probability.
Yeah.
Okay.
So let's erase this and we can take more questions.
Oh, sorry.
Next question. Okay, we have the solution of this one. We'll have a good look at it so that we can just review. Did we get the right answers? Yes. Can you please see? Oh, yeah. So, well, the first one is 2 over 75. The diagram, yeah, that 2, correct. That's what we get, right? Then we have 11 over 36, which we are looking into this row. And then we have 25 over 27, which is 25 is here. And we're looking into this. Is that clear? Not S, correct?
Yeah.
So now let's look into example 4, humanities. So what did you learn today?
I learned a lot. So we've carried on from last lesson, which was just kind of understanding the basics and knowing what dot A and C and union means in terms of like Venn diagrams and shading, which I was trying to get my head around because I found that really, really tricky. So now I thoroughly understand that. And then we moved on to conditional probability, which was the main thing I took away from that was like the restricted sample space that we have to have in mind, and the fact that when you change the probability or when you like use the new term that we had today, which was like probability of being given A, make sure that the restricted domain is going to change. So we saw that with the two-way frequency table and how the totals changed, and so it's very important that you be aware of that because then the probability could be wrong otherwise.
Correct.
So that was really clear. Thank you, sir.
Great. So we can end the class here. Good, you have learned. And we'll continue from here next time. Okay,
yes,
then?
will do, sir.
All the best.
Enjoy the rest of your day.
Thank you. Bye.
Bye, sir.